This is geotrig, day 2 of lesson 8. We're going to finish it up today. This one's talking about proportional segments, which happens to be, they want us to show that A plus B over A is equal to C plus D over C, which actually means B over A equals D over C, where A and C cannot equal 0. We will show that step in a little bit, as in I'll show you guys after we establish the ratios to be the same. We'll show this. Now, hey, look at this. I've got parallel lines. That's what X and Y are. I know they're parallel lines cut by transversals because they're different looking. I don't know if you guys can picture that. They're being darkened for a reason. They got arrows here as well. So you know that line X and line Y are parallel. Do you guys recognize two triangles?
Yes.
So I have a larger triangle and then a smaller triangle. The only vertice we happen to have is M way up top. We don't necessarily need those all the time, but I think everybody should be able to put our sides on. Like, what is this side?
A plus B.
It's A plus B. It's this A part plus the B part. So this is A plus B. The bottom is Y, and the other side
C plus D.
C plus D. Is everybody okay with that? I can also do the same thing with a small one. The small one is what on the left? A. Bottom.
X.
And C. Everybody's okay with just looking at that diagram, breaking it up. I hope by now that we've done enough problems where you have to break it up. Break it up before we put things back together. Now, we also have a lot of other things at those angles. You notice that technically they both share this guy up here, the top corner at M. The rest of them aren't named, but that's a single tick mark. They come from the same angle, so therefore, yeah, they share it. But notice that if you have parallel lines cut by a transversal, guys, this is the transversal right here. That's one of them. Then these guys, this angle and that angle, have to be the same because they are corresponding angles. Corresponding angles are the same. So this angle and this angle are the same. Same thing on the other side with a different transversal. That's a transversal. Now it's cutting the parallel lines that way. So this is the same there. Can you guys at least agree with that? Now, in the past, I said, hey, we have our statements of similarity. Those statements of similarities from yesterday allowed us, or had us, we'll say, state that two triangles were similar by placing the vertices letter that corresponded to the same angle in the other triangle. And that by putting them in a particular order, I would actually know my corresponding side comparisons, right? Corresponding parts that have a similar ratio. I can't do that with this one without having to come up with another letter for the bottom two vertices. Actually, the bottom 4, because these also have to have vertices, yeah? So, I'm not going to do that, but do you see that these two triangles here are laid down the exact same way? I don't need to rotate that. I don't need to flip it. They are laid out. So, in this case, could I state sides that are in the same ratio? Someone give me one. Let's do left over the right.
A plus B over A.
A plus B over A, as in this side is over this side. Yeah. Another one? C plus D over C. Last one?
Y over X.
Y over X. Look at what we were supposed to show. What were we supposed to show? A plus B over A is C plus D over C. Wait a minute. Those are those over here. Am I done? Yep. I showed it. I showed that the ratios it wanted me to show up in the show this is in the ratio of the sides. That's all you have to do.
What about the rest of the problem?
Yeah.
What about the rest? What is the rest of the problem asking you to do?
Which means that be whatever.
Okay, we didn't get to that yet. Okay. There's something cool about this. Now, if we ignore this part, that's just like an afterthought right now. Did we show this?
Yes.
Yes. Technically done with the problem. Now, there's a reason why I wanted to highlight this, or the book wanted you to highlight this. Let's think of this. How can I change this ratio supposedly to mean this? Do you guys notice that you would have a common denominator for both of these? Like, can I split this up? So couldn't I write that as A over A plus B over A? That's the left side. What would the right side be? C over C plus D over C. What's A divided by A? It's a 1. What's C divided by C? And if 1's on both sides, could I subtract it out? So would that just be gone? And what are you left with? B over A is equal to D over C. Wait, I got a question. Where do we see B, A, C, and D? Where are those things located by themselves? Are they all by themselves over on these?
No.
Oh, here's an A and a C. Now, look over here though. An A, a B, a D, and a C. See, wait a minute. So you're saying that when you have parallel lines and you cut them by transversals, I can actually say that B over A, which is this segment divided by it's the one above it, is equal to D divided by C? That's pretty cool. Guess what? Not only can you state that, I'm going to change colors so I can leave the screen here. I can also state A over B is equal to C over D. What I'm saying is I can put this segment of A over B, and that will equal the same ratio of C over D. What happens if I put A over C? What is that going to equal? What would that equal? B over D. There's one more. What's the last one you think? C over A is equal to D over B. Now, I did hear someone, or a couple people actually, chimed in. They wanted to put A over D, C over B. That is actually not a viable option. I cannot cross my sides. I have to keep it top over bottom equals top over bottom. I can do bottom over top equals bottom over top. I can do left over right equals left over right. Or I can do right over left equals right over left. 4 different ways to do the exact same problem. Seem pretty cool? Hey, what if I said all of these were parallel? And I cut this one like so, and I cut this one like so. Every single one of those segments formed like A, B, C, D E, F, G, K, right? Yeah, I did that on purpose. Someone's going to be freaked out about that one, I guess. But, hey guys, look at this. Let's talk about this. That means, I don't care how many parallel lines I have. These are all parallel, 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 and parallel. Okay? A over B will equal K over G. A over C will equal K over F. D over E will equal C over F, or B over G, or, okay, you guys get this? As long as I keep it consistent. Notice that when I said D over E, you have actually 3 other options because there are 3 sets of segments. You just cannot, guys, you cannot cross your division. Okay? So we're going to take that, because what happens here, guys, I could eventually say, I think everybody would agree, that these 2 lines would eventually, coming off the screen, be at a point somewhere down here, right? And wouldn't those form just 2 different triangles with any of those sets of numbers? And therefore, you can set up the similar triangles, la-di-da-di-da, statements of similarity, which then says that they are proportional. So, without having to go through the whole entire proof, can we just safely assume that it works? Yeah. And that you can use it? All right. Can we move on? And so that's what I put here. This thought process can be extended to any number of parallel lines that are cut by 2 intersecting transversal. Bless you. So, part number 2, find x. I'm going to give you guys a couple seconds here. I'll pause the video. On the video, it'll seem like mere non-seconds went by. Now, I'm going to set this up probably differently than about 90% of you. Tell me if I'm wrong. Is that wrong? No. Why is it not wrong? Because I just went left over right. The cool thing is, it's not wrong because when I go to multiply, guess what? My corners are still connecting the same pieces together as the ones that you guys chose, correct? So I don't want you to erase your work. Keep going. Yes, if you have something that looks like this, then you're on the right path. Cross your corners, cross multiply. Then what should I do with the 19 and the 13? Distribute. Equals 13x plus 52. Your choice. Move 13x or 19x. Why? So we can try to keep things positive, yeah? So that means I will get rid of 19 then. So these are gone, those are gone. What is 13 minus, or 19 minus 13? 6x equals 52 minus 19? 33. Divide by 6. X equals 33 over 6. I don't like that, so we change it to 11 over 2. Make sure you're always reducing your fractions. And if you really feel inclined, you can go to 5.5. Now, guys, I was asked a lot of questions about this today. I personally would rather see 11 over 2. If I was going to use that number, maybe check it, then maybe I would take a calculator if I didn't know, but then I can go to 5.5. But when you're working through all of your work, you should have it listed as the improper fraction. And if you feel like it, go to decimals. But I should be able to see the flow, right? I still see all of the work and the progression. What I don't want to see is 5.5, done. To me, that means you probably looked at someone else's paper and you just took their answer. How is that showing what you know? Take me on the road trip through the problem. Any questions on that? And without going through a formal proof on this, how do you think we're going to mix, actually before we do that, angle bisector. What is an angle bisector? Yeah, a line that cuts the angle in half, or two equal pieces. So, what they're saying is, this guy right down the center here happens to be an angle bisector. And if it's an angle bisector, it cuts this angle in half. That's why they put tick marks on there to say they're the same. So anytime you have a triangle that happens to have an angle bisector that cuts through it, what do you think is going to happen with those signs? Someone give me a good guess, an educated guess on how you can use those letters connected. A lot of blank space on here. You guys paying attention? We just did this a whole bunch of times. Well, A over C equals B over D? Yes. So let's just accept this. We could go through the proof for it. I don't want to right now because we just did a lot of other proof stuff. So let's just make things go a little bit faster. The ratios of the sides still work. So therefore, you can do A over C equals B over D. You also can use what? I'm not going to write all these down. What else? C over A is equal to D over B. Or A over B is equal to C over D. Or B over A is equal to D over C. 4 different ways to do the same problem. So I'm hoping you guys find these not to be too bad. They're going to go fairly quick, and we're happy about it. So in this case, find x for me in part 3. Notice that it's telling you that you have a triangle ABC. It's telling you that BD is an angle bisector, bless you, of angle B. And now that you know that, that means you can use corresponding sides and ratios. So, what's the setup?
10 over 15 equals x over 12.
10 over 15 is equal to x over 12. I think it looks good. I could have had this set up 3 other ways. All give me the same answer. But if you notice, I would rather, when I'm working with variables, try to have them on top. So this would be one of the options I would choose. The other option I would choose would be x over 10 equals 12 over 15. That's another option. But the other 2 still work. What's 10 times 12? 120 equals 15x. Divide by 15. X is equal to 8. And there you go. Are there any questions on that? Again, I think these are actually fairly nice. And then, of course, they're not all going to be sitting looking like this for you. And so, can I turn the page? They're just going to twirl it around a little bit. Does that really change it that much?
Yes.
No. It's still telling you you have AD, which is an angle bisector of an angle. Hey, look, now I can set my ratios up. Please do this. See if you can get the answer. Without any help. What's the setup? X over 6 equals, what was that? 20 over 14? Everybody agree? Yes. So cross multiply 14x equals 120 divided by 14. X equals what? 60 over 7. Done. Lesson 8, day 2, page 65, 4 through 11, and 25. Have a great day.